Are we? All right, looks like we're live. So today's video is going to be a brief overview of the issues that occur on the 12-inch Retina boards with some tips. This is not going to be a real-time video because I've been screwing around with these for a while and waiting for parts to come in, so I can't really do it real-time. But I just wanted to go over some of the things that I've found that go wrong with these and what chips you should and should not stock after I bought a collection of almost every chip for the damn board. So the first one that I'm going to be going over here is the 820-00224 board. This is for the 2016 12-inch Retina and one of the more common confusing issues that I've had with it. So the first is on this machine, the charger voltage is going to come in through the charging port, which is J9600. So J9600. This here is your USB-C port. And out of that USB-C port, you're going to get PPV bus LIO, which is going to be the 20 or 5 volts, depending on what the USB-C charger negotiates. And that over here is going to go to F3050. And that's going to come out as PP20V USB-C XA V-bus F. And that voltage is going to go to Q3100, which is a transistor that's going to let that voltage go through to the rest of the machine. Now, this is very similar to the inrush limiter on, let's say, the 3115. So if we were to go over an older machine that's a little bit more familiar, we are all familiar with the ISL6259 chip. The ISL6259 chip controls these two transistors here that allow the charger voltage over here, PPDCN, to flow through to the buck converter for PP bus G3 hot. And you have something very similar happening here. In order for PPV bus LIO, which is the charger voltage, to go through to the machine, it has to go through Q3100. Q3100 is a standard dual P-channel MOSFET, to my knowledge, and it's not going to open unless the voltage in the gate is lower than the source, and the gate is always going to be linked to U3100, which is a USB-C port controller, and this USB-C port controller is doing a lot of what the ISL6259 was doing on the older models, which is controlling whether this inrush limiter, this Q3100 transistor, sends charger voltage to the machine. Now, very often, what you can do is if you measure the voltage on PPV bus LIO or on this fuse, and it's the same as the voltage at the gate of this transistor, and this transistor is not opening, it's either the transistor is bad, or this chip is bad, or this chip is not receiving the information it needs to allow this gate over here to get shorted to ground or go to its internal voltage divider and lower. So over here you can see that you have this voltage divider of R7085 and R7086 on the older machines, which is going to allow the voltage in the gate to be lower than the source of the transistor that lets the charging voltage through. And that's not going to happen unless the ISL6259 over here decides to short the bottom of this resistor to ground so that it can be a voltage divider. Now, on the 12-inch Retina, that entire voltage divider is hidden inside of U3100. So U3100 just has a line between the gate of the transistor and this. And what I found is that if this transistor is not opening, that U3100 is actually the chip that's bad and at fault, and I can show you that here. That is this chip, and yes, I did jump the fuse because I knocked it off the board like an idiot. But I will be replacing that later. So this is what U3100 looks like, and this is a very common thing to go bad on the 2016 12-inch Retina. This over here is the transistor, and this is Q3100 that I'm pointing to, and this up here is U3100. So when you have the same voltage in the gate and the source of Q3100, I would check U3100. That can be bad, and because I am a shill, I will shill my website where you can buy this over here at mailin.repair, and there is a link in the description below. I searched a long time to find this chip because with all the Googling I did, I could not find anybody selling this. There were a lot of, like people think, look at this, like Google gives me eyeglasses. I mean, So it took me a while to find this chip, but I finally found it and got to fixing the stack of machines here that had issues with it. It looks like this, and it's a BGA chip. What I would recommend doing is when you're soldering this, you can take a shield, like a metal shield. This is a shield from a dead iPhone, and I just use it to cover the connector so that I don't destroy the DC-in connector, since destroying this thing is very, very easy. It's very delicate. So if you're going to be doing BGA rework on this, do cover the connector next to it. Now, the next thing I want to go over is the 2015 12-inch Retina. The 2015 12-inch Retina has a different set of standard failure modes that I've noticed. So let's open up the schematic for that. That's the 8200045 board. And that has a very, very common failure mode that is different from this one. So let me find my 8200045, and here we go. Off to the races. Now, one of the issues I notice on this is that you'll be getting something like only 5 volts on the DC in, and the 5 volts will make its way to the machine, but the machine won't turn on, and the charger will never go up to the voltage that it's supposed to be, which is typically 20 volts. So let's go over and see what one of the most common things is here. Now, there's a power rail. It's PP3V3 R. Here we go. So one of the very important power rails here is PP3V3 R3V0 underscore AON. And this power rail is important because this power rail powers many of the components. Hey, that's interesting. It's completely ignoring my PDF reader. Oh, well. What are you going to do? All right, go back to this. Let's see. Can I make my PDF reader take up the whole screen here? PDF. All right, let's try this. Put you on top, and bam. Okay, so just for the time being, let's have the PDF reader take up the entire screen. So let's go over what PP3V3RV-AON. So that comes from U7100, which is the ISL chip. That's very similar to the ISL6259. It's essentially responsible for those same functions on this board. Now, let's see what this power rail goes to. This power rail is used for almost everything responsible for USB-C charger detection. So, for example, like all of this USB muxing over here, because you have to remember, on this machine, the USB mux, the USB-C port is kind of like a cloaca. You know, it gets used for it's your multi-purpose orifice, your multi-purpose port. It gets used for charging, USB 2, USB 3, DisplayPort, Thunderbolt. That port it's used for everything, and it makes the muxing circuit a little bit complicated here. Oh, almost forgot to have my shilling. My shilling must remain on top. Let's get my shilling up. Yeah, shilling. Awesome. So PP3V3R 3V0 underscore AON goes to this chip for USB mux. It goes to this part for USB mux. It goes to just about everything, really. So let's go over the most important part of this. Now, this rail very often shorts to ground. And one of the things that sucks is that it often shorts to ground as a low voltage rail with a high resistance to ground. So usually it has, hundreds of thousands or hundreds of thousands of ohms to ground, which is standard, but it will go to, like, let's say 50 to 300 ohms to ground, which is high enough to be a short. I mean, it's low enough to be a short, but it's high enough that you're never going to be able to find what chip it's coming from, and that's a royal pain in the ass. So you can inject 3.3 volts, and even if you freeze spray it, you're never going to see what gets shorted. I actually wasted a can of freeze spray on this just in the hopes of finding it. So let's go over what. Here we go. So what I've noticed is that when there is a 300 to 400 ohm short to ground on this line, typically the culprit is this, U4700. So if you measure and you see that PP3V3 is missing, R3VO is missing, and you have a 300 to 400 ohm short to ground, I would say 99% of the time, the chip that's bad is U4700, this SLG4AP645AV chip. Now, if you measure and you have a 0 to 70 ohm short to ground on that line, then often the issue is the ISL95530HIZ chip. And I haven't gotten to a point yet where anything other than these two chips, except for maybe one or two that I wound up filming early on, were the cause of the short. So on the 2015 Retina, the first thing I would check for if you're getting 5 volts instead of 20 on DCN and it's dead is PP3V3 R3V0 underscore AON working. And if it is a 0 to 50 to 60 ohm short to ground, blame U7100. And if it is a 300 to 400 ohm short to ground, I would blame U4700. And because I am a good shill, I've left links to these two below, and you can also see that we have them in stock. So check it out. So we have this here, and Open Broadcaster is losing its mind, it seems. Let's see. Yep, Open Broadcaster is losing it. So, and we have the ISL chip. So, wow, that is. Let's see, if I use a different browser, do I have the same screw up? Huh. Let's see if. Is display capture still going to be screwed up if. Eh? Oh, it's gone. Huh. Hope my GPU's not dying. All right. Let's add window capture. Add exist. Huh. No. No. Lame. Of course, it always breaks in the middle of a stream. Ah, well. Huh. Yeah, 3D rendering. Oh, yeah, you have to disable hardware acceleration or something, but FFI got time for that. So, if you... Should I just point the camcorder at the monitor? Either way, if you go to the website below, you'll find that we have both of those for sale, the ISL 95530 and the SLG 4AP 645 AV 6100. Might as well show you what those two look like over here. So this is the ISL chip, and this is a bit of a pain in the ass because the ISL chip is BGA now, by the way. So this is our new ISL chip, which is BGA, not QFN. And it's also surrounded by very tall capacitors. So if you want to see what the balls look like under it, good luck with that one. You can see what the ball on the left looks like, and that's pretty much it. Yeah, let's see if I can get that under the microscope for you. Yeah, so you can't really see every ball anymore, which makes it a little difficult to check your soldering. So just, and of course, don't knock off any, don't knock off any of the stuff next to it. That will be no good. And U4700, which is going to be, let's see, I believe it is down here. I'm just going to double check to make sure I don't, not talking out of my ass. U4700 is, no, opposite side, over here. So this over here is U4700. And these are easy, more simple to solder QFN packages, and I would put a shield over this stuff around it just to keep yourself safe if you're using hot air. So do something like this with a shield. And you can find these shields on dead iPhone boards. You could use a quarter if you wanted to, probably, or a penny. I would use a penny because I'm cheap. And there you go. So you block it off, and now you can remove your IC. And that's about that. So that is some of the most common issues I have found with the new 2015 and 2016 12-inch Retinas. Hopefully now you can avoid buying almost every single chip on those two lines to try to figure it out, with me saving you some time. And best of luck and happy fixing.